Hi, my name's Simon Elliston Ball, and I'm a product manager for cybersecurity. Today I'm going to tell you a little bit about how we use Apache Metron to process network telemetry data. So the first thing we have to do is start off with some network telemetry data. So we have a variety of different data sources that we work with. We tend to bring in a lot of log data, a lot of cloud type data. We also bring in things like IDS data, Bureau data for those who are doing deep packet inspection, things like your auth logs from AD. We have cloud logs from AWS, Azure, GCP, you name it. We can bring in any kind of data that we like. We also bring in things like print server logs, any kind of log that you might find useful from a security perspective. Now, that's a wide variety of data, so the first thing we've got to do is turn that into something a little bit more meaningful and consistent. That's where the parser layer comes in. We have parsers built into the platform for a variety of different common devices, such as firewalls, for example, proxies, those kind of things. And those produce a nice, clean, simple key value form of data, which then goes on its way down the pipeline. So next in the pipeline, we want to enrich that data. So we will add in things like geo-enrichment data, things like asset databases, things like user databases, all kinds of additional data sources to make that a little bit more meaningful, add some context around it. We then look at how we can bring in some third-party data, such as threat intel feeds, and often this will come in the form of things like STIX data, STIX threat intel data over the taxi protocol, and that will then get added to the message as it goes through, so we can detect things like bad domains which are known to threat intel providers. We then come on to the stage where we do a lot of the deep analytics, a lot of the special source in Metron, which is in the profiler. And that's where we add a little bit more context around time and the behavior of users across different peer groups, for example. And that profile will then also feed back round into further enrichment of the data so that we add more context to that message as it's going through. Once we've picked up all this context, decided what we now know about this original telemetry message, we have to figure out whether it's important to an analyst. And that's where the triage stage comes in. This is where we take all that accumulated information and decide whether it's worthwhile being an alert, also how important that alert is, so how high it should appear up your analyst's queue. So that's where we add scoring and multiple rules to the messages. After that, we have some nice complete messages, lots of context, score and a priority against it. We index that out into a variety of different destinations. The main historical store is in the Hadoop HDFS system, and that will give us the ability to do things like run long-term models, train machine learning models, for instance, and also dig deep into long-term forensic analysis of that data. We also write out a shorter term period of data, usually a month or so, into something like Solar, which provides us a much more near real-time search capability and gives us the ability to add dashboarding, faceting, slice, dice, and some of the high-speed visualization pieces which are also included in Metron on top of it. So that is the journey that a piece of network telemetry data will take through the Metron pipeline. Thank you very much.